Hello class, today I would like to lecture section 6.3 about binomial. Um, I would like to start with opening up the PowerPoint and guide you how to work on this section and understand this section carefully. We having the in front of me is chapter 6 here is saying that we learn what you learn in chapter 6 is modeling random events. uh, for random events we learn the normal distribution and a bit about binomial models. Binomial models and normal distribution, they are kind of similar, um, just a little bit different. However, we still run stat quants with different steps a bit, just a little bit, and you will see it. For section 6.3, you learn mainly about binomial models. Plus, there will be some question on 6.2 that you learn from previous lecture, just like kind of a review, and then some question for 6.3, like multiple choice for us to do. For this binomial model, how do you know that is binomial model? Right, that's the question. And how do you find probability for that model? So for this one, the first thing you need to identify in the in the prompt, um, you look for the four following procedure. First, a fixed number of trials. So usually it's like they given us how many times of something and how many trials of something. So usually that would be notate at small n, like a sample size, right? And secondly, all the time we so in the prompt they were talking about a story. For example, if we're talking about a coin, we only have a head and a tail. So they are called the possible outcome, right? If I toss a coin one time only. But if I toss a coin two times, then the total of the outcome will be differently. So we will have the different probability for each outcome. So for this case, they would like us to look for, we only have two outcomes possible for at each trial. Okay, at each trial, for example, like I said, a coin. Um, a coin only have two possible outcome is a head or a tail, right? So that is what it means. And the probability notation for probability will be small p of a success. Is the same at each trial. Trial. So this is what does it mean? Um, the word, the probability P of the success in this case uh, is mentioned about um, the number of the thing that you want to set at a success. For example, again, I repeat for flipping a coin. So if you name probability of finding a tail will be a success, then it is the probability of the success. But if you like the head to be the probability of the success, then um, small p would be um, the probability of the success of the tail of the head. Okay, you know what I mean? So it's depend on the question and depend on you. But usually the question will ask really straightforward. So you don't have to decide is it head or tail would be the success for me. You understand? So later, hopefully we have some good question so that you can see clearly about the idea of it. Fourth, the trials are independent. It mean each trials have to be like separately. They are independent. They not affect of each other. Okay, like I said, probability of a head is 1 out of 2 if I toss a coin one time, and probability of a tail is also 1/2, as same as probability of the head. So like the trials separately, like they got they don't affect each other. Head is head, tail is tail. It's like that. And again, if you have any question, email me right away. Okay. Okay, so here they have example of tossing a coin. Suppose you toss a coin 8 times this time. You toss a coin 8 times and count the number of heads. Explain why this is an example of binomial experiment. So, so you look back the four procedure that we need to identify this is a binomial or not binomial. And the step would be the following. So first, you know that the number of trials is A. Go back to the question. Suppose you toss a coin, one coin 8 times, right? 8 times, that's the number of times, which is n is 8. You toss a coin here, when you're thinking about a coin, you know it will be a head and a tail, right? And count the number of the head. Explain why this is binomial. Now I guide you to step 1. So we have found that n is 8. And secondly, each trial has only 2 outcomes, heads or tail. And third, the probability of a landing on heads is same at each trial, which is 1/2, right? So all the time we're talking about a coin, doesn't matter how many times that people toss, but all the time you will get the number of head will be the same thing with the number of tails, will be 50%. Fourth, trials are independent because outcomes of one toss does not affect of the outcome of any other toss. And again, if you have any question, please email me. So now binomial or not binomial. So the following are some example for us to identify when you're reading it. And again, in order to decide binomial or not binomial, they have each of this have to qualify 4 steps, right? So let's look at the first one. Record the ages of a group of 20 randomly selected statistics students. Okay, let's take a minute, think about this question. Is it binomial or not binomial? Number 2, ask each partner of a married couple whether or not they exercise regularly. Please think about this question. Number 3, ask a random sample of workers whether their annual salary is greater than $50,000. So those type of question, it won't be on your test. However, it's like for you to identify and know when you will apply binomial, when it's not, and then you. So this sentences is just like actually it's just like the obvious picture. Because the actual problem, they have a lot more information for us to compute. So for this one, it's just like identifying, okay? Okay, to answer this question, okay, so you did answer in your head. You might answer right, you might answer wrong, but it's just, it's okay with practicing. And like I said, within 4 four step that you check if if one of this question, for example, question number one, if it's not satisfying um, compared to one of the four, then it's not satisfying. Okay, so let's check the solution. So question number one, and here's the answer. This is yes or no. So let's read out loud with this one. I'll record the ages of a group of 20 randomly selected statistics students. This is not binomial, and why? Because each trial does not have only two possible outcomes. So that is the reason why it's not binomial. Question number two, and answer and solution for number two as well. Ask each partner of a married couple whether or not they exercise regularly. And this is also not binomial because the couple is married, right? So it's look like they depend on each other. They depend on each other. So the trials are not independent. Number three, ask a random sample of workers whether their annual salary is greater than $50,000. And it is binomial is because um, so when you ask this question, people will answer, yes, I make more than 50,000. No, I make less than 50,000, and so on, right? Yes, no. So this is binomial. So that is how you kind of recognize um, the binomial, but usually the example for this binomial is like you win or you lose. You toss a coin, you got head or tail. Um, or obviously female or male, stuff like that. So it will be binomial. But you again, we should check the steps. If they have enough information, like the number of trial, the probability of the trial, actually the probability of success, and you know if they are independent and stuff like that. So you check those kind of quickly, then you figure it out. But mostly when if I write the question about binomial, I will obviously give you all the information. Then you just apply how to compute that. So for in this lecture, I will direct you how to apply on TI-84 as well as on StatQuant. But usually I prefer on StatQuant because it's more like convenience. Um, but when you do the test in the face-to-face, it's rather using TI-84. So I teach you both. Here is the shape of the binomial distribution. The depend on the story. Every single story they have different shape of the binomial distribution. And again, um, for example, for this one, the we notice that n is 15, which is the number of trials, and p equal to 0.30, which is 0.3 or 30%. So this is the probability of the success. Okay, we have this too, and we having the column. You see the standing up, the vertical line standing up, that's represent for probability, and the horizontal line, that is the number of the success. You see that? So for the first dot, let me annotate that you can see it. For example, for this dot, see that? So the number of success for this one is like a 0 point something, right? And the probability of is also a 0 point something as well. And here is represent for one, right? The number of success is one, and the probabilities might be like maybe half of this will be 0.025 for that one, for example, and so on. They have this, that, how many, number of success for this one. For example, this is three, and you notice the probability for three success is, it looks like they add 0.15 for each, right, to get the next value. So right here, it might be, let me, 0.05, I'm sorry, they're adding 0.05. So this will be, did I say wrong? So for example, right here, they add So from here to here, 0.05, they add up. From here to here, 0.05, they add up. And they add 0.05 to get a 0.10 plus 0.05. They got 0.15. So here's like half of it. So you're gonna cut like you add a bit 0. You got 0.05 divided by 2. You got half of that here, and you add with 0.15. This would be 0.175 or something right here for this dot, and so on. So each number of trial, they have different probability of the success, different probability, and the probability of the success will be the given probability um, for the specific number of success that they give us. And when they're using the technology, they got all of this value. As you can see, so total is like 15. When you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and here is 15, right? So you count one from here. Recount for me. You got like 15 of them. It's maybe zero doesn't count. You count from one. Okay. So total is 15. So each trial they got their own probability right there. Um, count by the number of success. And we will having different probability for each number of the success. Okay. And this 0.3 here is the probability of the given success that is not really related to each of this. So if they want us to compute each of the number of success down here, you want to use that probability that given, and you use n is equal to 15 to figure it out the number of success down here. Okay. Right now it's kind of, yes. It might be like too much information, and you know do not know how and how. But again, here I just introduce you what is binomial distribution. Like how does it look like? Is it all the binomial distribution look like this shape? No, the answer is no. Each binomial distribution have different shape depend on the story. But for this case, then they got this value, um, as you can see. But if you want to know really specific story for this one, please go back to the e-text, log on Pearson, go back to the e-text and type on. Let me show you. You go to Pearson, you log on Pearson, right? You go to video and resource library, you click that, and it leads us to this. Let me erase this. And then you click here, you will click chapter 6. You got many ways to get into the resource, and then you can click multimedia textbook. Because PowerPoint is what I'm using for lecture. If you want to see clearly with the textbook, or you can log on e-text on the first page, like home page. So let me check this. And you click on the 6.3. I'm showing you where is the PowerPoint got information. PowerPoint is like like a summary of the textbook. They summary all the important information. But if you want to know like clearly what is happening, what is the story is about, so the textbook have more information for those who are curious. So like this one, you see that they give us the definition of the binomial model. It's just like the PowerPoint. They just summarize for us, and they having kind of like more story for us to read over. If you kind of not really get what's happening, you should spend time reading this too. So here is another example about binomial distribution. You see that the shape is not look like the shape for the PowerPoint because why? Because they give us different story. So let me open up the shape for this one. This story is a different story than the textbook, but for PowerPoint, they just like bring out the just one example only, one or two specific example, not like detail like the textbook. Again, if you want to read more story, please spend time read on this too. For example, for this, talking about what binomial distribution have n only 3, right? N is 3, and P is 0.5. The probability is 0.5. So now you can see the shape is kind of symmetric, and we are having um, zero of success. Zero of success is mean, for example, if you're talking about a coin flip one time. For example, you got head and tail. Let me write it down so that you can see it. If a coin flip one time, you got the outcome will be head or tail, right? So like this. And so this for this case, for this case, the probability of a tail is 1/2. And another word, they will say the probability of zero success. So let's activate the number of the success, and we have 0 of success. And we only, for this case, we only see head or tail. So, and 0 success is 1/2 as well. So in this case, a head right here that I squared will be called the number of the success. So that is probability is x is 1, number of success, because we only have one head, right? But if they setting up like different question, for example, let me see. For this one, they have to divide evenly out. Okay, so if they talking about, let me see, a binomial n is 3 and p is 0.5 is symmetric, we can read from the graph that probability getting exactly 2 successes is mean they consider success be ahead in 3 flip a coin. Okay, so this example they're talking about flip a coin 3 times. Is for this example, flip a coin 3 times. But when you flip a coin 3 times, in order to gather this information from the graph, you have to write down all the outcomes that the coins have. For example, flip a coin 3 times, you can either have, the total outcome will be like about 8. So we are having head, that is one outcome, okay? And we have head, tail, and then we have head, tail, head, and you keep finding all the outcomes, and then you will compute. So let me erase the example for flip one coin so that I have more space to explain to you, and hopefully this makes sense to you as well. Let me see. Okay. I try to explain to you to understand why they got this picture from the story. Okay, and we have so keep going. So I know the number of the outcome for this case is like total is 8. So I keep figure it out. The my outcome next we have um, head, tail, head, and we have tail, head, head. Yeah, tail, head, head. And then we have what else? We have head, 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 tail, head, tail, head, tail, head, head. Um, we have, let me see, tail, tail, head, tail. Right, tail, head, tail, 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 head. We have what else? Tail, 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 and head, tail, tail. Is it all? Okay, 1, 2, 3, 4, 5, 6, 7, 8. So please let me know if I do wrong, okay? Okay, so I found this outcome, and for example, I'm having this, for example, this zero number of success. In order to figure out the zero number of success, I'm looking at my outcome. I have zero to success. I use different color. This, which is this, tell. That is probability when my number of success is zero, which is the probability of tell, only one outcome, which is 1 out of 8. So you help me compute is 1 out of 8 is how much? Let me using my calculator. 1 divided by 8 is 0.125. So this equal to 0.125. So 0.1, maybe over here is 0.125. Okay, so that is how they got a number of zero success, or which is tell for this case. And so this is the way that they draw. They just like drag all the way up, and then stop at the value that we have. And for example, secondly, so let's check out the probability of one success, which means the probability of one success is x is 1, or in other words, probability of we only have one head, right? So let me count. How many do we have? One head only. We have here. So let me erase the one head tail. Okay. I found here. I have found here. And I found here. So I found 3. So that means I have 3 out of 8. 8 total out of the outcome. So which is I use my calculator to figure it out. 3 divided by 8, 0.375. It might be right here is 3, 0.375 over there. See that? And it's all the way down. Number 2, two head is just the same thing. 2 head, which is probability of x is 2, or probability of 2 head, exactly 2 head. Okay, they don't say anything about at least, at most, or more than or something. So here we just find the exact value. Again, I'm using maybe different color, maybe a brown color. So 2 head I count is here is 1, here is 2, here is 3. So that is only 3. So then I have, again, is 3 out of 8. And same answer with, we have 1 head. So that's why you got is even, right? It's just like the same height. And so on for all the success, which is 3 head. Then you will find is 1 out of 8 again. And we got the probability like 0.125 right here. So here it said, so this again, n equal to 3 is mean like flip 3 times, right? The probability of the success right here is mean for each trial, the probability that they get ahead, like the probability of the getting ahead and a tail is like 50-50 if we're thinking about one coin. So that's what it means for the probability of the success for this case. and n will be supposed to be the time that the coin got flips. Okay, class. So that is how you do it, and figure it out. Do this by we could call this binomial distribution. And I go back to the PowerPoint. Like I said, if you're curious more, like the story is where does it come from and stuff like that, you help me keep keep clicking and fighting with um let me I'm trying to find if someone curious like where do they got the information from. Okay, in the textbook they have um many questions like that. So maybe this one is the one that we talk about. Let me go back to the PowerPoint to see it. Okay, that's not two. See that? So all the binomial distribution, they got different shape depend on the story. So the purpose here, like I'm not gonna give you like you need to identify this picture, that picture. But what I want you to do is you understand um, how do you got this, how you got that by reading more from the textbook, or if you understand from the lecture already, you don't need to read more. But I'm still recommending you to keep reading more to understand carefully. Okay, it looks like I cannot find the example. Um, it might be. Oh, this is the one. Okay, page 299. Let me erase that what I wrote up here so that you can see clearly the example. So this is the example from the PowerPoint that just pull it out, and I believe it is. It looks like the shape. It looks like they're talking about a coin again, and the number of times they flipped is 15. So let's compare back to the PowerPoint. See it? Oh no, it's not the one. Okay, so here, so actually, the goal for this one, like you understand the process that how they got it, right? But some question they having like a lot of and it's like very big. Uh, n is more big, it make the binomial distribution become normal distribution, which is become the kind of symmetric shape, like a bell shape, which is you learn in 6.2. It's just the same thing. Um, and Okay, so let's go back to this anyway. So like I said, I explained to you how do they got this. First, they have to having or what or you looking at the picture and figure it out right away. If you got a ruler that you figured out the probability of zero success for this case is x is zero is about 0 point something for this case. If you divide it for this one, maybe like this is 0 0.01, right? It's roughly like that, and so on. You can continue counting for each of this. You can figure out the probability of the number of the success. Next, and for this shape, so this shape is the shape we got from the textbook. It's maybe we don't I don't want to spend time searching the textbook, but you can help me to compare. So this one is from the textbook that we stopped, I believe, right? Is that n is 15, p is 0.5. You see that? And go back to the PowerPoint, right? We got this, right? Just the same thing. So you'll see here too many shape. um, Binomial and normal distribution like kind of similar because like I said, when n is increasing, uh, from binomial they will make the distribution become normal distribution, which is this. on the right side, as you see right here. See that? We have n this time is 100, and the shape like really like a bell shape right now. This one is n is 15, is almost a bell shape, or it is a bell shape as well. We go back to the previous slide. We got a bit skew on the right side. However, so this time is n is 15, p is 0.3. It's kind of, yes, kind of like 80% symmetric. So we are having the number of success increasing as well. So right here, the purpose for this part is they want us to know binomial and normal distribution, they are related. So finding binomial probabilities can be found by hand using binomial formula if n and x are relatively small. Like I said, if I give you like n is only 1 equal to 1, or n equal to 2, n equal to 3, n equal to 4, it's kind of easier for us to compute by hand. But usually, like they said, we have to use technology anyway to do it. So here is one of the example. Let me see if I can help you understand this example. Finding binomial probabilities for one value of x. According to recent Pew poll, 47% of the Americans say it is important to control gun ownership in a random sample of 200 Americans. So we know that n is 200 right now, and we know 47% would be the probability of success. Find the probability that exact 90 Americans say it is important to control gun ownership. So they want us to find probability of when x is 90. So it's like a huge number. So we cannot compute by hand for this time. We have to use technology to do it. Right? So we find this probability. So how to, for TI-84 or compute by StatQuant, you will see that the process is also written in here as well. But before you're doing it, I recommend you to listing out all the information that they've given us. You got n is 200, you write n equal 200 on your notes. And then you write p is 0.47 on your notes. Of course, all of this like usually is binomial. Mostly they're asking you question, they are binomial. As your question relate to like kind of like that would be binomial, I'm sorry. So in this problem, we are looking for the binomial where the binomial probability where n is 200, p is 0.47, and x is 90. So so we use the notation B stand for binomial, right? B and then parentheses. When you were using the calculator, you got 200, you write n first and p and then x value. So we're having the following. So using StatQuant, so I'm going to using StatQuant to demonstrate for you to see it. How do I compute? We have all the value n, p, and x already, and this because they don't say at least or at most, we have to use we find probability of x equal to 90 by using StatQuant now. Okay, so let's check it out. So now I'll open StatQuant. I go back to the main menu. Called StatQuant. When you log on, then you can access for free. So I'm gonna using data set from the textbook, but I do use StatQuant from StatQuant website, so that I can enter whatever value that I want. You open StatQuant. You go to stat, you go to calculator, you go to binomial because this is binomial, right? So they given you this shape, so it doesn't matter. Your job, you enter the value that the textbook want us to do, I remember is n is 200 and p is 0 0.47. 47% you convert into decimal will be 0 0.47, and x right here is 90. However, you have to be careful here, less than or equal to, or because you said exact, so you have to put equal. If they said um, at least or at most, so less than or equal to is mean at most. So here at most, right? So here will be at least, right? Greater or equal to will be at least, and here is less than, it's like below that, right? Below 90, and then here greater, x is greater than 90, which is you figure out a value like 91, 92, 93, 94, and so on. So here equal to will be exact. Then you click compute. You got compute, then you see that the probability that we found is 0.04821566. You route to, you can route to 100 place. Actually, the more value that you place, the better. I prefer to 1,000 place, which is here you see the 2 is smaller than the 8. You leave it there. So it means you ignore 21566. You only keep 0.048 for me. But like in case like, okay, you want to route to 100 place, that's okay for me too. If you route to 100 place, you got 0.05, but again, I really want to see a 1,000 place. The reason I would like to see the 1,000 place is because it's more accurate than you route to 100 place. You got that picture, you got the shape, so let's go back to the PowerPoint to see it if we got the same value. It is. Okay, so they, and here they want us to route to 1,000 place as well. So I really appreciate if you keep to 1,000 place. Okay, so that's how you got it, and how to got binomial and so on. I did explain to you how to use at least, at most, for binomial and probability already. So you just keep using step quants by using those steps, and find the probability for binomial. That's it. So I think that's all that you need for 6.3. And for the following slide, this tell us more about like example, um, more example for you to practice. If you, I did posted a PowerPoint in section 6 of section 6.3 under chapter 6. You can take a look at to find more example for practice. Okay, I would like to go a bit over for those who are who using TI-84. TI-84, you using TI-84, then you have to press second dist, which means second distribution, right? Second dist, and then you select the binom PDF, and then you need to enter the binom PDF parentheses have to be exactly the same. N will be 200, P, which is the probability of success, X with the value that they want. In case that they say at most 90, so you should push the lower value, which is like 0, maybe 0 first, comma 90 to figure it out for the words at most. But you using at least, then you type 90 and then comma the highest value, like you can put like 1,000 for example, like that. Then you press to figure out a probability. Give very high value so that you know that usually people are using like 10 raised to 99, which is very huge number, which is they say all the way on the right side, or maybe like on the left side they use very like negative value, big negative value, to say that okay, that's just my left tail. But if you don't like that, you can write only like negative 1,000 or something, comma 90. That means you count from 90 and below. Okay, so that's how you're using the calculator with TI, and that's how you run stat quants to figure out binomial. Okay, class, for other slide, no worry about that. But if you curious more example, please go over it. read over this, try practice on your own, figure out what is P, what is N, and then right here say find probability of three or fewer. See that? Or work unemployed. You know three or fewer, which mean X will be 0, 1, 2, and 3, and so on. And you figure it out. Please spend time, read more on this, and practice on your own, and you can figure out the solution. Okay, that is all the information for 6.3. Please email me if you have any question with regard to a binomial. Okay, and see you next time. Please don't forget to email me if you don't get anything. Thank you.